Hello everyone, welcome back to my channel Learn with Mukul. So in this video I am going to teach you about the basic concept of CPU scheduling algorithms. So in this video I am going to teach you what are the algorithms which is used in CPU scheduling, which are basically FCFS, SJF and round robin algorithm. FCFS stands for first come first serve, SJF stands for shortest job first, and third one is round robin algorithm. So basically CPU scheduling algorithm means it is a process of determining which process will own CPU for execution while another process is on hold. Like suppose there are two processes. If process 1 requires 10 seconds and process 2 requires 5 seconds, if the CPU had decided to complete one particular process, suppose P1, so it will give 10 seconds to complete that particular P1 and keep that P2 on hold. This is how CPU scheduling algorithm works. So there are basically two types of CPU scheduling methods. First one is preemptive scheduling, second one is non-preemptive scheduling, and which is also called no interruption, and preemptive scheduling, which is called interruption. Means in preemptive scheduling there is an interruption, there is a breakage while the process is being executed, and on second, which is non-preemptive scheduling, which means there is no interruption while the process is being executed. Now there are some important CPU scheduling terminologies which you should know while dealing with the numericals of these three types of algorithms. So first one is burst time. So it is a time required by the process to complete execution. It is also called running time. So basically burst time means the total amount of time taken by the process to complete its execution. So it is also called running time. So it is called burst time. Second is arrival time. When a process enters in a ready state, it's called arrival time, which means when the process first came at a CPU, so it is called the arrival time. What is completion time? At what time the total execution has been completed of the process. Completion time, at what time the total execution has been completed of the process, which means at what time did the process has been completed. Fourth one is throughput. Number of processes in per unit time by CPU, means the number of processes which can be executed in per unit time by CPU is known as throughput. Fifth one is waiting time. For how much time the process has to wait in the queue. Suppose there are two processes, P1 and P2. P1 requires 10 seconds and P2 requires 5 seconds. P1 came first, so CPU will deal with P1, and for 10 seconds it will keep on executing P1, and till that time P2 will be on hold. So how much time the P2 is on hold, it's called the waiting time. Now there are three, I have already told you there are three CPU scheduling algorithms, which are FCFS, SJF and round robin algorithm. So I'm going to teach you all of these three algorithms one by one. So there will be three videos of this playlist. The first one will be FCFS, then SJF, then is round robin algorithm. So today I am going to teach you about the basic one, which is FCFS, which stands for first come first serve. Let's jump back to the numerical. Now this is how the FCFS work. So in your exams this type of questions will be coming to solve the FCFS, which means the question will be calculate the average waiting time. Before I tell you what is average waiting time, I will tell you what are these abbreviations. So AT here means arrival time, BT here means burst time, CT here means completion time, TAT here means total arrival time, WT is waiting time, and RT is response time. Now look, in FCFS, which is first come first serve, the criteria used here is arrival time, which means in FCFS you need to follow the order of arrival time, who came first and who came last. Now, and the mode is non-preemption, which means there will be no interruption while the process is being executed. Now this is how a numerical looks like in FCFS. There will be a table in which there will be the number of process, and arrival time will be given for that process, and the burst time, which means the total time taken for the particular process to be executed. Now there are certain formulas for calculating this TAT, WT and RT means CPU first minus AT, which is arrival time. The process first came to the CPU at what time minus the arrival time, it's called response time. And TAT means total arrival time, which means completion time minus arrival time. and WT means waiting time, which is equal to total arrival time minus burst time. So this solve this particular problem, first one is using the Gantt chart. The Gantt chart includes two methods, which is ready queue and executing queue. So make sure to note that concept that ready queue and executing queue run parallelly, which means ready queue and executing will work simultaneously along with the flow. Okay, now I'm going to solve this particular problem, so make sure you pay attention what I'm doing. Okay, now you always need to start with the ready queue, and there will be a two rows. First one should be the I will show you what is it is, and second one is the timing. Now I'm going to start the question. Now check at 0, is there any process which arrive at 0? Yes, it's P4. So right here P4. Now P4 has arrived at 0. Now executing queue. Now the CPU will execute it. So check for how much. Here will be P4 and 0, because why I have written here 0, because the starting it came at 0 and P4 has arrived here, it will be executed. Now see for how much time the CPU will give to this P4. It's P4, it is burst time. So 0 plus 3 is 3. Now go to the again ready queue. Now see if there is any process which has arrived at 1. Yes, it's P3. Right here P3. Now P3 here in executing. Now CPU will execute P3. Now look, P3 requires how many time to execute, which is P3 it's 8. So 3 plus 8 is 11. So till now our P3 and P4 is done. Now see if there is process which has arrived at 2. Yes, it's P1. So right here P1, and see P1 here as well. And to the right, because P1 first got its interaction with CPU at 11. Now how much time does P1 require? It's 6. So 11 plus 6 is 17. Now see if there is process which has arrived at 3. There is no process which has arrived at 3, so that CPU will be sitting idle, which is free. Now is there any process which has arrived at 4? Yes, it's P5. So right here P5. Now how much time will the CPU give to this P5? We will see through this burst time of P5, which is 4. So right here 17 plus 4, 21. So till now our P5 and P1 is completed. Now see, is there any process which has arrived at 5? Yes, it is P2. And how much time is required by the CPU to complete P2, which is 3. So 21 plus 3 is 24. So our P1 and P2 are done. So by this you can see that our all processes has been executed by the CPU. Now we will complete this following table. So in the question you will be asked what is the average waiting time. So for that you need to solve this CT, which is completion time, total arrival time. Then you will be able to find what is waiting time. Now first of all is completion time, which means at what time the CPU has released the process after being executed. Now look, the completion time. What is the completion time of P1? You always need to look upon the executing queue while dealing with this particular table. Okay, now in executing queue, in P1, at what time did P1 got completed? See, it's P1 here, so it will be 17. You might have a doubt, why not 11? Because at 11, when the time was 11, P1 arrived here, and how much time was required? It's what, 6. So 11 plus 6 is 17. So it's got completed at 17. So right here 17. And P2. And now see P2. Yes, it's 24. With that flow, complete all the table. For P3 it's 11. For P4 it's 3. And for P5 it's 21. So with this our completion time column is completed. Now coming to the total arrival time. For the formula to calculate this total arrival time, we have a formula which is CT minus AT, which is completion time minus arrival time. So 17 minus 2 is 15, 24 minus 5 is 19, 11 minus 1 is 10, 3 minus 0 is 3, and 21 minus 4 is 17. So with this our total arrival time column has been completed. Now we have to do the waiting time. The formula of waiting time is total arrival time minus burst time, which is 15 minus 6 is equal to 9, 19 minus 3 is equal to 16, 10 minus 8 is equal to 2, 3 minus 3 is equal to 0, 17 minus 4 is equal to. Now response time. Now RT, it's called the response time, which means how much time does the CPU is requiring to respond to that particular process. So how to do this response time, how to solve this response time column, which is CPU first minus arrival time, which means at what time the CPU first interacted with that particular process. Now check for P1. The P1 got its attention at 11. So 11 minus 2, which is arrival time, 11 minus 2 is 9. And so now for check for P3, it's 21. P3 so 21 minus 3, 5 so is 3 minus 16, 1, which is arrival time, and for which will be 3 minus 1 is equal to 2. And for P4 it will be 0 minus 0 is equal to 0. And for P5 it will be 17, which means P5 17 minus 4 is equal to 13. This is how we complete this. So this is how we complete this particular table of FCFS. Now we need to check the average waiting time, which will be equal to the sum of all these processes waiting time divided by number of processes, which will be 40, which will be 16 plus 9 is equal to 25, 25 plus 2 is equal to 27, 27 plus 13 is equal to 40. So 40 divided by 5 is equal to 8. So the average waiting time comes to 8. So every process needs to wait for average of 8 seconds for the turn to be executed, so that CPU can be executing that particular process. So this is how FCFS work. I hope you liked my video. If you like it, then please like, share and subscribe, and do comment on my video. So in my next upcoming video I'm going to teach you about SJF, which is shortest job first. So thank you.